The neuroanatomical basis by which neural circuits mediate behavior. The human brain carries out actions in ways no current computer can begin to approach. Merely to see, to look onto the world and recognize a face or facial expression entails amazing computational achievements. Indeed, all our perceptual abilities, seeing, hearing, smelling, tasting, and touching, are analytical triumphs. Similarly, all of our voluntary actions are triumphs of engineering. Sensation and movement, while wondrous in their own right, pale in comparison to complex cognitive behaviors such as forming memories or understanding social conventions. The language of medicine and health, engineering and behavior, in other words, matter and our dominance in silence. In some other language other than the English, so confusing studying neurology, I can barely begin to explain how creepy the man is who talks to me as an ant. Microwaving my food, watching him stack the beer with his twisted cold face and his fucking tattoo, staring at me dead in my eyes. The brain accomplishes these computational feats because its nerve cells are wired together in precise functional circuits. The brain is hierarchically organized such that information processed at one level is passed to higher level circuits for more complex and refined processing. In essence, the brain is a network of networks. Different brain areas work in an integrated fashion to accomplish purposeful behavior. In this chapter, we outline the neuroanatomical organization of some of the circuits that enable the brain to process sensory input and produce motor output. We focus on touch as a sensory modality because the somatosensory system is particularly well understood. And because touch clearly illustrates the interaction of sensory processing circuits at several levels, from the spinal cord to the cerebral cortex. Our purpose here is to illustrate the basic principles of how circuits control behavior the authors talk about in their language. In the next chapter, we consider the functional properties of these circuits, including the computations by which they process information. Information on the internet, information on a device, information on a tablet, information on a computer, information in a book, read by a human. In subsequent chapters, we consider in more detail the anatomy and function of the various sensory modalities and how sensory input regulates movement. Movements such as going to find food where there's no nutrition. Movement to leave Earth. and go to another part of the planet in outer space. And movement, lastly, pushing stop on the cellular phone